Lee.
Here.
Saran.
Here.
Sky.
Here.
Starry. Summer. Summer.
Absent.
Absent. Thank you. Sylvia.
Here.
Terry. Tom. Vincent.
Here.
And William.
Hello.
Hello. Okay. How were the exams yesterday
Bad.
and this morning?
Bad.
Good.
Terrible.
Which one was the easiest?
English. English.
Really?
English.
They gotta
Kill him.
And it's only good English. There's no choice.
So frank. English is very simple.
Very simple.
So very awful.
I wish I could say the same about Chinese. I was Chinese. Okay. Do you guys have homework for me?
Yeah.
Pass up your homework. I'll take it in. I asked some people before class, how was the homework? The last two questions were a little difficult.
Yeah.
But as long as you understood this,
Yes.
what is this?
Reaction.
Reactivity. Reactivity series, yeah. If you understood how to use this, the first part was pretty easy, right? More towards the top, reactive, right? More towards the bottom,
No reaction.
no
No
reaction.
reaction.
Less,
No reaction.
less reaction.
No reaction.
Yeah, less reaction. So, Lee, which is more reactive, calcium or iron?
Calcium.
Calcium. You didn't even have to look. You have it memorized.
Yeah, I remember that.
Okay, good. Angelina, which is more reactive? Magnesium or zinc? Magnesium. Yeah, it's higher up. Okay? Okay. So we understand the reactivity series. What does it mean? What does it apply to us? That's what we're going to talk about today. Yeah, we use the reactivity series all the time, everywhere. So you're going to learn about some ways that we do displacement reactions with the reactivity series. Yes, exactly. Okay. So if you have your green notebooks, open your green notebook. Oh yeah, from last class. Open your green notebooks. We only have 2 words today. Copy. Yeah, copy these 2 words. Yeah, because we didn't discuss it though. You guys wanted to see the Minecraft slides. Molten and all. Yeah.
I didn't put the Minecraft for
This one?
Yeah. Good.
What would you call this?
Lava.
Lava.
What is lava?
So which one is related to lava? Molten or
Molten.
yeah, molten lava.
Ores.
We'll talk about molten
What does
later
spin
on.
mean?
And what about this? What ores are in this photo?
Diamond, gold, diamond, gold, iron, gold, iron, coal.
Teacher.
Coral.
Okay, coal. Yeah, surround.
You've written that a still solid has been heated to become liquid. Why lava? Lava is already liquid.
There's ores inside. Well, lava is molten because it's been heated up. It's hot. So if it cools down, it's no longer molten.
It was already being liquid. Then it gets solid.
So this liquid is molten. When it cools off, it won't be molten anymore.
Oh.
Molten is liquid. But I can tell you that aluminum's reactivity is between zinc and magnesium.
Why
Okay?
we didn't you put it?
Did you want to write all the elements? These are just the most important ones.
Oh, most important.
Okay. I'll pop this up here as well. I think we had Saran and Vincent, just because you guys are close. Can you stand up?
Okay.
Did I have you guys do this last time?
No.
Okay.
Gravity.
So we said aluminum is less reactive than what? William? Magnesium. Aluminum is more reactive than iron.
Then zinc, iron. The down one.
Yeah, all of these. The important one is
Iron.
iron. So if we have an iron oxide, this was in your homework, so aluminum will displace the iron, yes or no?
Yes.
Yes. Place.
Yes?
Yeah, because iron is less reactive.
Yeah.
Iron is less reactive.
Iron is less, aluminum's more reactive.
Yeah.
So Saran is aluminum, and
I think
Vincent is iron. I'm the oxide. Okay?
Displacement.
Yeah, displacement.
I will come and grab.
Yeah. Saran is more reactive than Vincent because he's aluminum. So Saran's gonna come over. He's gonna say, "Hey, what's up? What's going on, guys? What's up? Hey, I'm the oxide, right? Vincent's iron. We're gonna go this way. Vincent's all by himself. Now, the iron that was once in the oxide is all by himself. Saran and I are together
Aluminum.
as aluminum oxide. Exactly. You guys can have a seat. Thank you.
I'm hungry.
Same exact thing. This is a pretty popular displacement reaction. Because if you put me, Saran, and Vincent, which is aluminum and iron oxide, if you put us together and then add a little bit of heat,
Yeah.
just a little bit,
Fire. Boom.
we're going to make a lot more heat.
Oh.
So you combine these two compounds,
Yeah.
add a little bit of heat, and in that reaction will make a lot more heat. A lot more heat. It's going to get really, really hot. Upwards of
1,538 degrees.
yeah. How hot is it gonna be
You
tomorrow?
can make something.
How hot will it be tomorrow? It's gonna be warm.
Yeah. 30.
That's good. Yeah, it might get up to 30.
33.
23 tomorrow?
30.
Even if it was like 30 degrees tomorrow.
200.
Up to 0.
Think about how hot that is.
You can make something.
Yeah. At those temperatures, what do you think can happen?
Milk.
Melt.
You can what?
Yeah. How much temperature would it take to, we'll use that, to melt this plastic ruler, do you think?
How much liquid?
To a liquid.
To a liquid.
500. 500.
Probably don't even need that much.
100. 300.
90.
No, I don't know the exact answer, but it's definitely a lot less heat than that.
Yeah.
Hopefully I grabbed the right photo. Where's Songjiang University Town?
No.
Left.
Okay. Here. Okay, so this is where we would be. What is this one? I have to assume it's pretty far away.
Yeah.
Any guesses? You're not talking about like a kilometer or two. Any guesses? How
7
long?
kilometers.
How many?
7.
7 kilometers?
I didn't that is.
Owen, how many kilometers do you think line 9 is?
I never.
50.
50 or 60?
Centimeters?
60?
35.
35?
No, I think it's
64. Yeah, it's pretty big. It's
Oh,
pretty big,
I was
right?
thinking. I said 7.
So you have 64 kilometers of railway. Do you think when these are made, they're made 64 kilometers long.
No, it was.
They're cut up.
Yeah, they cut up. And there was a thing that they push it into the line.
Yeah, they can bend it. They have them cut up. And we're going to see how they reattach them.
It can take so much space to build all 64 kilometers. No.
Okay, this video is about 2 minutes long, and then we'll watch a real life version. Thermite, kind of the same thing.
There's no E.
Let us weld 2 railway tracks along their ends using thermite welding.
What?
So this might be,
The track.
30 meters long. This one might be 30 meters. They're going to put them next to each other, and they're going to use the thermite reaction,
To make it.
which is a
Join it
displacement.
together.
Yeah, exactly.
First, pour the hot molten wax between the gaps of the tracks to form a wax pattern. Then install a welding setup around the rail ends as shown.
Join it together.
Now bring a box containing thermite mixture.
What do you think is in the thermite mixture?
I don't know.
Aluminum and iron oxide.
I don't know.
Aluminum and iron oxide.
Exactly right. Yeah.
Which is basically a mixture
The equation we were just looking at. Yeah.
of aluminium and iron oxide.
Just a little bit of heat. So they've combined, and now they're heating it up just a little bit. When the reaction starts, not kaboom, but
We see that
it's going to
in
get very
fire,
hot.
both the aluminium and iron oxide
So Grant, once the molten iron has cooled, is it still molten?
No.
No.
It's solid.
turns
It
to
becomes solid.
Solid. Right. So molten is only used to describe the liquid form, right? I'll skip around this 3-minute video. This is the same thing, just in real life. What's inside there? Yeah. What'd they just do? A little bit of heat. Look how quickly it went. Look how hot it got so quickly.
Teacher, look at that. It's all
We said
steel metal.
the reaction can get up to 1500 degrees Celsius, right? And it turns the iron molten. What do you think the tub is made out of?
Steel.
What do you think this is made out of?
Steel.
Steel.
Zinc.
Steel.
Zinc? Steel?
I think iron.
What is
Calcium? I don't know what it is exactly, but it's got to be something that has a higher melting point than
Yeah.
iron, right? Otherwise it would melt too, right?
Yeah.
It looks very thin.
So that's how they connect them.
The hammer never melt. The hammer never melt.
Also must have a higher melting point. Okay. And then they grind away the rest. That's pretty obnoxious. Okay. So for about 3,500 years, who's the oldest in the class? Raise your hand if you're 13. 14. Any other 14? 14? 13? Raise your hand if you're 14.
I'm 15.
Raise your hand if you're 15.
I'm 10,000 years old.
I'm a dinosaur.
You guys remember how old am I?
I think Spirit is the oldest. Spirit is the oldest.
18. 10 years old.
25, yeah. 25.
Robot dance.
Okay. Imagine, you've been living for quiet. You've all been living for about 14, 15 years.
I am over 5,000 years old.
We've been using carbon to displace other metals that we can use to build things for over 3,500 years. Long time.
Long time, right?
Carbon is more or less reactive than iron.
More.
More.
This kind of displacement.
It displaces, yeah. It displaces the iron.
So it is more iron.
It is more, yeah. So here's another reaction that we do. This one's also only 2 minutes. Okay, why is this important? What are we making? It's molten what?
Iron.
Aluminum.
Iron. What do we use iron for? What do you think? That's not the end of the class.
It's 20. It's not good.
Yeah.
有个零是小心。
What do you think is in this pillar right here? Do you think it's just there because it looks nice?
Plastic. No.
Plastic?
Hold the building.
Hold the building.
Yeah. There's probably a steel beam in there
Yeah, obviously.
holding the building.
Or
You go into any building, they're using steel
some barrel.
in some way to hold the building up. This is how it's made. This is how that steel is made. Okay. I have 3 questions on here. We have a little under 10 minutes left. I'd like you to answer all 3 if you can. Start with the first one. Huh? Okay, I want to take this in at the end of class. So you'll all give this back to me before leaving. Okay? How do you know that? This should help you with the first question. Reactive. Iron is less reactive than aluminum. That would be grammatically correct. Saran's already on the second one. Impressive, yeah. He's almost done with the second one. Okay, anybody else want to give me their homework? No, I haven't finished yet. We still have 30 seconds.
Friday.
Give it to me Friday if you haven't finished. I got everyone's homework? Okay. Angelina's just so excited to leave. Yes, you can all go. Thank you. Bye-bye. Yeah, give me your papers before you go. Thank you very much, Julia.
No idea.
Do you have yours? It's okay if you haven't finished. If you've got at least one of them, then I'll take it out. I'm not going to grade it. Yeah. Papers? Mine? It's Howard. Papers?